Hello guys, in this video we are going to start a new chapter, that is data link layer. In this chapter we are going to read about data link layer and its various protocols. Now in this chapter, first of all, we are going to read about what framing is. So we earlier read that what frames are. Frame is the PDU, that is protocol data unit of data link layer. Whatever the data link layer gets from the upper layer, that is network layer, it converts it into frame. Alright, so it basically moves frames, those frames that it create from one node to another. Now what framing is? On receiving, the data link layer needs to pack bits into frames. Now this receiving means that when it receives data from the upper layer, that is network layer, the third layer is network layer from down to upwards, and when it receives data from the upper layer, network layer, it packs those data, those bits into frames so that each frame is distinguishable from another. Alright, this basically is framing. Now, physical addressing. A frame is the encapsulation of header and trailer information with the packet. In header, the source and destination MAC address are dealt. Now basically a frame is what I told you now, it is going to get the upper layer data, that is network layer data, and is going to encapsulate it with something. That something is going to be header and trailer, a header and trailer. In that header part will be having the MAC address of source and destination. Alright, now data link layer has two sublayers, that is LLC and MAC sublayer. Now we are going to read about these two sublayers. Alright, so as you can see here, the LLC, logical link control or data link control, okay, DLC sublayer. This handles communication between upper and lower layers. Alright, it will take the network protocol data and adds control information to help deliver the packet to the destination, that is flow control. So this layer, this LLC, is going to manage the flow control, okay, and it will manage the connection between upper layer and lower layer. Okay, the another one is MAC sublayer. This is the important sublayer implemented by hardware, typically in computer NIC. We are going to read about this further after some few lectures. Now what MAC sublayer is? We read here that it is implemented by hardware, so it is implemented in a hardware stuff that typically in computer NIC. NIC is a kind of a card that is installed in your computer. Now what are the primary responsibilities of this MAC sublayer? So at very first, it's going to encapsulate your data, that is, it's going to it assembles the frame on the, whenever you are sending some data, then it's going to assemble it as frame. Your data first is assembled as frame, then is sent to the destination, and after it is received, then it is going to disassemble. Okay, the frame what was assembled earlier is now going to disassemble. So my side, if I am a sender and you are a receiver, so my side data link layer is going to create a frame, and as you are a receiver, so your side data link layer is going to disassemble that frame upon reception. Now this layer adds a header and trailer to network layer PDU, making it a frame. This is what we read earlier. It's going to add a header and trailer to the network layer PDU, to the data that network layer created, making it a frame. That stuff is going to turn as frame. Now media access control is also property. Here other responsibilities are framing MAC or physical addressing, MAC or physical addressing we can say, because the header contains the destination and source MAC address. Alright, this will help the data to reach the destination. And finally, it also does error control, and it communicates directly with the physical layer. So these were some stuff about MAC sublayer and logical link layer. These are the two sublayers of data link layer. Alright, now look here, it's written over here that, look, when two nodes are sharing data, then to make a frame, a set of zeros and one is added in the data. And in the header and trailer part to look, whenever a node will be sharing a data, then some set of zeros and one are added in the header and trailer to generate a frame. Okay, so these now though the frames that are now generated are only understandable by the data link layer, and to physical layer it's just a bunch of zeros and ones. The physical layer cannot understand or cannot distinguish a frame. Okay, thus the frames are not distinguishable by the physical layer. To solve this problem, 11011, these bits are added in the start and end of a frame to make them distinguishable by physical layer. Look, suppose this is the data that you created, 0 1 0 0 1 1 and all the way to 0 0 up to this is the data that you created. Now how do you distinguish a frame in physical layer? Like, how are you going to make two frames distinguishable from each other? Of course you have to make it unique so that it doesn't mix up with the data, and the integrity of your data remains intact. So for that purpose we add this sequence in the starting and in the ending. Okay, so we do this. However, now suppose now you are also able to look here. Look, this 11011 is here, and this, look here, this 11011 is also in between the data. So the receiver computer might misunderstand, actually it will misunderstand this like this is the ending of this frame. Okay, and the other data that is still the part of the actual data will not be considered, and at the end of the day this is not going to be successful communication. Look, here it is written, because data can also include this, so it can make the receiver incorrect about the frame distinguishing. This is called framing error. So this gives birth to framing error. What framing error is? When you are sending data and you made sure that that frame will be distinguishable by adding a starting and ending sequence, special bits that will make the frame distinguishable from another. However, that same sequence bits appeared in the data too, and now the receiver misinterpreted that data, misinterpreted that frame. So this leads to the rise of framing error. How do we solve this framing error? We are going to read about this later. Very first, we are going to read about types of framing. So we have fixed size framing. In this, basically we are going to send, suppose we have a lot of data. Now we are going to break that data into 10 bits per frame. Okay, now I will be suppose I send you 100 bits. Okay, so you know, cause I will be only sending a frame in the form of 10 bits, so you know that now I receive 10 bits, this makes one frame. After receiving the another 10 bits, that will be another frame. Okay, so this way you will be able to distinguish among different frames. This is a technique of fixed size framing. Okay, now what variable size framing is? Now this size of each frame can be different here. So the size of frames that were equal, so we read here that 10 bits each frame. So they were constant here. However, this is not going to be constant in variable size framing. So additional mechanisms are kept to mark the beginning and ending of the frame. Okay. Now various framing approaches. So there is a bit oriented approach and there is a byte oriented approach. Now in bit oriented approach, this will be viewing, as you can see, as you can interpret from the name, bit oriented approach. So it's going to view the frame as a collection of bits. In bit oriented framing, data is transmitted as sequence of bits. Now data transmitted as sequence of bits can be interpreted in the upper layer both as text as well as multimedia data. Okay, so the data that is going to be transmitted as a sequence of bits is going to be interpreted in the upper layer both as a text as well as a multimedia data. The main highlight is that it views the frame as collection of bits. Now some protocols that are in bit oriented protocol is, actually there is only one protocol, HDLC, high level data link control. Okay, so this was about bit oriented approach. About this protocol we are going to read this in this video. We are going to study this just after reading byte oriented approach. Now as you knew that in bit it was viewing the frame as a collection of bits, so it makes it obvious that in byte oriented approach it's going to view it as a byte collection of bytes, not of bits. This time it will be bytes. So it's written over here, one of the oldest approach to framing. This is one of the oldest approaches to framing. In this, each frame is viewed as collection of bytes, characters, okay, rather than bits. Each byte has 8 bits. Okay. Now byte oriented protocols, there are 3 protocols: BISYNC, DDCMP and PPP. A BISYNC is binary synchronous communication protocol and DDCMP is digital data communication message protocol. PPP is point to point protocol. We are going to read all of them in the next lecture. Okay. Now the third one is clock based framing. This is the third approach. Example, SONET, synchronous optical network. Okay, here we have the bit oriented protocol, that is high level data link control. So high level data link control's frame format is going to be like this. Okay, now you are encapsulating the frame with a beginning sequence and an ending sequence of 8 bits each. Okay, this is the frame here. Look, here is header, body, CRC, and these are being encapsulated by a beginning sequence and an ending sequence. Okay, now beginning and ending sequence both are of 8 bits. Header is of 16 bits. Header will be containing the MAC source and destination MAC address with some other informations. CRC is a error detection. It will be of 16 bits. Now body size can be determined here because it depends upon what the network layer will be sending you. Okay, so it is variable. Now beginning and ending sequence. This is going to be this beginning and ending sequence in HDLC protocol. This will be 0 1 1 1 1 1 1 0. So there is 0, 6 ones and 0. This is going to the beginning. This is going to be the beginning and ending sequence. Whenever the link is idle, not working properly or something like that, then this sequence is also transmitted in order to synchronize the receivers and senders clock. Okay. Here header. Now the components of this frame format are defined like header, address and control field, body, payload. The body simply is the data that you get from the upper layer. CRC, cyclic redundancy check, error detection. We are going to read about this in the later lectures. Now, types of HDLC frames. There are some types of HDLC frames. The type of frame is determined by control field, that is in the header. Okay, So there are three frames: information frame, supervisory frame, unnumbered frame. If the first bit is going to be 0, first bit of frame is 0, then it is an information frame. If it is 1 0, then it is supervisory frame. If it is 1 1, then it is unnumbered frame. Okay, so this was about HDLC protocol. So far we read what framing is, physical addressing, data link sublayers, then framing error, then types of framing, fixed and variable, then approaches to frame that are bit oriented and byte oriented. Now in HDLC we read the protocol that is used in bit oriented. Okay, now we are going to read about bit stuffing. We saw the framing error. What is the solution to that framing error? Here is the solution. You see, here there is a beginning sequence and an ending sequence. As I told you earlier, in the HDLC protocol, this is the beginning and ending sequence. However, look here, this same sequence also emerged in this data, so it certainly is going to be interpreted wrong. Okay, this is the actual frame. However, the interpreted frame will be up to this one. This is going to cause framing error. How do we solve it now? Now, in order to solve this, what we are going to do is we are going to put a 0 after 5 consecutive ones. That is, now there is a 0, 1, 1, 1, 1, 1. 5 ones are now here. If another one comes and then 0, then it is going to be a framing error. So we are going to put a 0 after 5 consecutive ones. Okay. Now you might be thinking that won't this change the data? My data is going to be modified by this stuff. Yes, it is. So now after doing bit stuffing, first let me tell you, this is known as bit stuffing. We stuffed a bit in the data to reduce, or we can say to eliminate, the framing error. Now as you might know, as you might be interpreting that this is going to cause a modification in my data, so certainly it is going to cause. Now how do we deal with that? So on receiving the data, the receiver, now suppose this data is going to be received by the receiver. Now he is going to remove zeros after 5 consecutive ones. So he is going to remove those zeros. Okay, and then creating the original data. The bits, the 0 that we stuffed, is going to be removed on the reception of the data. Okay, so this was about bit stuffing. This was all for today, guys. In this video we read about, as I earlier told you, framing error, then bit oriented approach, byte oriented approach, their protocols, and in the next video we will be reading about byte oriented protocols. Alright, thank you guys for watching this video. I hope you enjoyed the session.